So now we're going to be getting into circular motion and gravity. And so we're going to start with the first question here. Semi-trailer trucks have an odometer on one hub of a trailer wheel. The hub is weighted so that it does not rotate, but it contains gears to count the number of wheel revolutions. It calculates the distance traveled. If the wheel, got a wheel here, has a 1.15 meter diameter and goes through 200,000 rotations, how many kilometers should the odometer read? I kind of reason these problems out. I don't use formulas for things like this because I figure I attempt to minimize the amount of formulas that I try to keep in my head. Some, they're just useful to keep in your head, but like something like this, I'm going to just try to reason out. See, what I think about is about one rotation. Always start with, I think, one, whatever is convenient for you, but I think one rotation, I consider how far does it travel in one rotation. One rotation, it will go the circumference of the circle. Okay, so the distance will be pi times the diameter, 1.15 meters times pi. Okay, so if I have 200,000 of these, I'm just going to multiply this by 200,000 to get the total number of the total distance after it's gone 200,000. 5 times pi. And that is 722,566 meters. And in kilometers, it's 722.6 kilometers. Just round it off like there. Okay. An automobile with a 0.26 meter radius travels 80,000 kilometers before wearing them out. How many revolutions does the tire make, neglecting to do the backup? Again, I consider what does one revolution entail? One revolution, or one rotation, would be 2 pi r distance, and that would be 2 pi times 0.26 meters. Okay, and so that would be some number, whatever number that is. That's when one revolution is the distance. So I want to know how many times that goes in to 80,000 kilometers. And I would do this in meters. So I'm going to divide this by 2 pi times 0.26 meters. And this would then be the number of rotations to get to this, that would be in there. 83 divided by 2 pi times 0.26. 9. I got 4.9, 1, 2, 3, 4, 5, 6, 7. 4.9 times 10 to the 7th rotations. Okay, so like 49 million revolutions. Rotations or revolutions. A baseball pitcher brings his arm forward during a pitch, rotating the forearm about the elbow. If the velocity of the ball of the pitcher's hands is 35 meters per second and the ball is 0.3 meters from the elbow joint, what is the angular velocity of the forearm? Okay, so we have this guy's arm here, and the ball is going out at this hand here at 35 meters per second, and this distance here is 0.3 meters, and this is how it's rotating. The question is what is the angular velocity? So here's where an equation I would memorize, and this is that the linear velocity is equal to the angular velocity times the radius. Okay. So in this case, I want to know what omega is. It's v over r. The linear velocity, which is the tangential velocity up here, is 35 meters per second divided by 0.3 meters. And this is 117. And then the units of this are going to be radians per second. When you use this formula, it's implicit that it's radians per second. It's not super obvious from the formula, but it is actually radians per second when we do this. And it has to do with the fact that the angular displacement and angular position are related directly in radians. So that's where it comes from. Okay, a truck with a 0.42 meter radius travels at 32 meters per second. What is the angular velocity of the rotating tires in radians per second? And what is this in revolutions per minute? Okay, so I have a tire here. There's a radius of 0.42 meters. And we're traveling at a linear basically, where is this 32 meters per second? It's the tangential velocity. Okay. And again, our equation that relates tangential to angular velocity is v is equal to omega r. So omega is equal to v over r. And the linear velocity is 32 meters per second. The radius is 0.42 meters. And so I get 76.2 radians per second. Now we want to convert this into revolutions per minute, and then we're just going to use dimensional analysis for this. So first I want revolutions on the top. So how does revolutions relate to radians? Well, one revolution is 2 pi radians. When I get 2 pi radians, I go around the circle once. And then now I want minutes on the bottom and seconds on the top. Well, 1 minute is 60 seconds, right? So answer divided by 2 pi and then times 60. I'm going to get 728 revolutions per minute. Okay. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.